Hello, Geodesy lover. Here's the second session, and we're talking about coordinate systems. And last time, basically, we stopped talking about the chart of coordinate systems. And as I said, this chart is very useful because it has all the coordinate systems used in Geodesy and explaining the interrelation that exists between each pair, and also the it specifies the origin of the system, if it's heliocentric, geocentric, or topocentric. Basically, we have to mention that the celestial coordinate systems in Geodesy, they are treated as geocentric, and we also have all these parameters that well, let me go and get a color here. Let me see, pointer options, ink color. I will stick with the gold or the red. So basically the parameters that we have indicated in red are parameters that are going to be used when we deal with the coordinate transformation. If we have coordinates in these LG local geodetic system, and then we want to go to the G system, for example, we require rotation matrices, and latitude and longitude, geodetic latitude and geodetic longitude are the parameters in this case. We also, okay, so the next slide is basically a text that pertains to the previous one, and the same as this one, because it talks about the characteristics of each one of these families of coordinate systems, the terrestrial coordinate systems, and what they're good for. There are coordinate systems for the positioning Earth located points, characteristics of the coordinate system. It is fixed to the Earth, so it spins and revolves around the Sun with the Earth, and two of them are topocentric, the local, geodetic, locostromic. All the rest are geocentric. Topocentric means the origin is at the topos, or the surface of the Earth, exactly at the observation point. Celestial coordinate systems, they are good for positioning of celestial bodies. They are heliocentric, in Geodesy treated as geocentric, and they revolve the Earth if they're treated as geocentric, but they don't spin. So they maintain a fixed orientation with respect to the stars. And the orbital coordinate systems, which are good for the study of our artificial satellites. They don't spin with the Earth, but revolve with it because it's geocentric. And again, of course, in Geodesy, they are geocentric. And the property of being geocentric makes these two systems here, the true right ascension system and the system of apparent places, to coincide. Okay, now a very important concept that we have to emphasize is the difference between a reference system and a reference frame. Okay, system and frame, they have to do with how we idealize something and how this thing that we idealized is made material, is made concrete. So here it is. System is used to distinguish between an ideal scale, okay, and frame, its realization. The scale here can be basically anything. If you think of a say if you have these newlyweds and they go well, a girl and a boy, could be two boys and two girls, I don't know, but anyway, the we have these newlyweds, and then the girl said, "Oh, hey, sweetheart, this is my dream house, and let's design that." And they go and make the design of the bedroom or whatever. The guy, "Oh, yeah, that's a very good house." So, and then they hire a contractor, and so what they have idealized, their ideal house, okay, this abstract concept, that's basically what we would call the system, is built. Now, when it's built, basically, well, the wire is not in here. There is then a crack in the basement, and one wall is thicker, and maybe the wall is going to be twisted, and so there are lots of different problems that are going to happen. Okay, so this is when you make the your ideal dream real. Okay, we'll call these in Geodesy realization. So the real thing is the frame. Okay, so in this example of the house, what we have basically is a say the design in a plant that comes from the idea of the dream of these newlyweds, and we call that the system. And when the house was actually built, was made real, that's what we call the frame. So the system may not be necessarily 100% satisfied by the frame, because we are taking a ideal idea and made it reality. So here's the thing: the system has to do with the definition. Okay, the definition of that abstract concept, and the realization or materialization will happen in our case in Geodesy when it involves observations. Okay, and then here comes the problem, because observations will have uncertainties, and we may have instruments that are not totally well calibrated, etc. So that creates a kind of it becomes nearly impossible to have to materialize or realize a ideal system. So reference system is for definition, reference frame for realization. So in practice, we do transformations between coordinates that come from reference frames. So here's something that is important to realize. Okay, so I'm going to stop in here just for a moment. Discard.